Hey guys, Mr. Ferguson here on Wrestling with Math, and today we're going to focus on arithmetic and geometric explicit formulas here. I have two examples up on my board. I have my arithmetic and geometric sequence formulas as well, so you guys can look at those. And I'm going to look at two examples here. So here we're creating the formula or the equation that we're going to use for these specific formulas. Okay. What we need to do first is, if I look at my first example, it'll give me three of the terms of the sequence. I have to determine whether or not it's arithmetic or geometric. So if you recall, I have to see whether or not it's an adding or subtracting pattern or a multiplying or dividing pattern. So if I'm looking here, and the way I told you guys how to do that was you take one of the terms and you either subtract the previous term if it's arithmetic, or you take the one term and you divide by the previous term. So if you're looking here, I have 33, 28, 23. If you could see right off the bat, I'm subtracting 5 or adding negative 5 here. And I would be subtracting 5 to get from the second to the third. So since it's constant here, adding or subtracting, it's going to be arithmetic. Okay. The number that it's changing by is your common difference. So I'm going to write off to the side d equals negative 5. A of 1 is your first term, which in this case is 33. And that's the only information I needed. N is your term number. I'm not finding a specific term like we did previously. I'm just finding the formula. So this is the only bit of information I need, and I'm going to plug it in. A of n equals A of 1 is 33 plus d. So you can do plus negative 5, or you can just do minus 5. Remember, the formula that they give you on that reference sheet, the common difference is at the end. I recommend putting it in front of the parentheses because we're used to distributing. And this stays as n minus 1. Okay, I'm done. That's my formula there. I don't have to do anything else. If I wanted to find, say, the 10th term, what I would do is I would plug 10 in for n, and I'd be able to plug this in. So this is an arithmetic sequence because we had an adding or subtracting pattern of minus 5. Another example here, the first three terms are 7, negative 14, and 28. As soon as you see it going from positive to negative back to positive, there's no way this can be arithmetic. There's no way I can add and go from negative to positive. So this is automatically going to check to see whether or not it's geometric. Okay, so I take one term, I'm going to take the second term, negative 14, and I'm going to divide by the previous term, 7. Negative 14 divided by 7 is negative 2, which means I should be multiplying by negative 2 to get my next term. 7 times negative 2 is negative 14. Let's just double check. If I multiply negative 14 by negative 2, do I get 28? Yes. So negative 2 in the geometric sequence, your common ratio, so r equals negative 2. A of 1 is the same as the arithmetic. Okay, so A of 1 is my first term, so A of 1 is 7. Now I can create my formula. A of n equals A of 1 is 7. Parentheses are key here. Negative 2 goes inside the parentheses. And then up in the exponent, remember this has to be up in the exponent, n minus 1. The whole n minus 1 there is up. So we have our formula here. We do not need to do anything else. If I wanted to find, again, say the 7th term, I would plug 7 in for n, and I would plug this into my calculator. Okay. Arithmetic, if you recall, was a linear function. Geometric was an exponential, which we'll get to those later on in the year. Okay. So two examples. Hopefully this helped, and thanks a lot, guys.